Okay, so we have the first one. It says, Bruce and Krista are going to buy a new furniture set for the living room. They want to buy a couch, a coffee table, and a recliner. So for number one, all right, this is my number one here. They want to buy a couch, coffee table, and a recliner. Okay, they have narrowed it down, so they're choosing between 4 couches. So these are 4 couches, 5 coffee tables, and 9 recliners. The question is, how many different combinations are they going to make? So, well, guys, when you do a combination, okay, what you're really doing for the combination is actually multiplication. So you're doing 4 times 5 times 9. Well, what's 4 times 5?
20.
And what's 20 times 9?
180.
That's how many combinations they have for the first one. All right? That's how many combinations they have for the first one. Okay, so number one for us is 180. So when you think about combinations, you got to think about what math function.
Mr. Christian,
Yes.
that's the statistics and probability, right?
Yes, sir. Statistics.
I don't have the same question for number one.
I know you don't, but it's pretty much similar to that right there.
Yeah. All right.
All right. So, okay.
Yeah.
The next one. So it says, Tasty Treats Baking Company asked all the students in the senior class at Ridgemont High School the question, do you prefer chocolate or butterscotch Tasty Treats? Everyone surveyed had to pick one of the 2 answers, and 42% said they preferred chocolate. So this is number 2. Number 2 says, so it's between 2 flavors, butterscotch and it says chocolate. I'll put C for chocolate. Everyone surveyed had to pick one of the 2 answers, and 42% said, so 42% they said chocolate. Okay. Based on the data, which of the following conclusions are valid? All right. It says 42% of all students at Ridgemont High prefer chocolate. 42% of all students in the senior class at Ridgemont High prefer chocolate. Or 42% of the male students in the senior class at Ridgemont prefer chocolate, but we cannot conclude anything else about the population. Well, the question is this: what sample was taken? Was it the whole school was taken? Yes or no?
No.
No. It only says
senior
The
class.
senior class.
only the senior class. The senior class does include the boys and the girls.
Yeah.
Yeah, they could be boys and it could be girls. Okay. So number one, it's definitely not the answer because it didn't talk about the 9th graders, it didn't talk about the 10th graders, it didn't talk about the 11th graders. Okay. C, it says 42% of the male students in the senior class. Did it ever say anything about the males?
No.
No.
No. So it didn't say anything about the males. So it has to be B because it says of all the students includes males and females.
Class.
Exactly. All right. Number 3. The histogram below shows the height in meters of the tallest building. All right. Move this up a little more. In China and the United States. All right, so let's scroll this down a little bit so we can see it better. So it says, which piece of information can be gathered from these histograms? All right, the United States has the tallest building, of these 2 countries. China has more buildings over 390 meters tall, none of the above. So the bottom part tells me the height, right? So if it's the height, the number of buildings that are between 240 and 290 meters, it's about 27, correct? That's for you, the United States.
Yeah.
Let's look at China. China, the number of buildings that are between 240 and 290 meters, it's exactly at 25. So we do understand the United States has more taller buildings, correct? So the question is this, the United States has the tallest building of these two countries? Pretty much yes. China has more buildings over 390 meters tall. Oh, I'm sorry, these are the smallest ones. Over here, the height over here, we have 540 meters tall. We probably have, for the United States, we probably have one. In China, we have 490 through 540. That seems to be the tallest building, okay? Which is probably like 2 or 3. So China has more buildings over 390 meters tall. Well, when we look at 390 meters tall for China, right? This one here, if we take a look at this one here, 390 meters, if we look at this column here, okay? We look at this column here, all right? We probably have around, let's say, 3. Between 440 and 490, we probably have 4. And between 490 and 540, we probably have what? 2. More or less, right? So there's be 7, 8, 9, there's around 9 buildings that are 390 meters or taller, okay? If we look at the United States, we have the United States is what? Here. Can write this down now. There's probably 1, 2, and 3 buildings here in the United States. So China has more buildings over 390 meters tall? Yes. The United States building has the tallest building of these two countries? Yes.
Yeah.
Right. And then none of the above. I think that's about it, right?
Yeah.
There you go. That's the piece of information that we have right there. Number 3. All right. What is the probability that Ronald will eat the next fry? Okay. So we have Michael, Ronald, Lydia, Alexandra, and Catherine. So there's 1, 2, 3, 4, 5 students or 5 kids or people are each sharing a basket of fries. The following table shows an incomplete probability model for who will eat the next fry. So guys, this is important because for number 4, let me write this down here for you guys here. So you guys can see it perfect. This is number 4. All right. When you're thinking about probability, the probability will always be, the maximum probability is actually 1. So if we take those numbers there, if we take 1 minus 0.3 minus 0.1 minus 0.32 minus 0.1 will give me the last probability of Ronald. All right. So I want you guys to work this out, see what you guys get. 1 minus 0.3 is what?
0.7.
Good. So we get minus 0.1. What does that give me? What's 0.7 minus 0.1?
0.6.
Good. Minus 0.32. What does that give me?
0.28.
And finally, minus 0.1. That gives me what?
18.
0.18. So that has to be the probability of Ronald. 0.18. We're good? All right, let's look at the next one. Noor and Rana are shopping for a Christmas tree. They are deciding between two different types of trees, real or fake. So this is number 5. I'll put number 5 here. Okay. So they're looking for a real or a fake. All right. They're deciding between two different trees, real, fake. So real or fake. And then they're deciding between 4 colors of the ornaments. So 4 colors. Okay. White, silver, gold, or purple. They each created a display to represent the sample space of random picking, a type of tree, and a color for the ornaments. All right. So let me see. Whose display correctly represents the sample space? Well, you see this one right here that was represented right here, real or fake. This is what's called a tree diagram. Okay, and I was actually going to do it for you guys right now, but it's already done. But I'll do it anyways. We start off with 2, real or fake. From the real, we could get white, silver, gold, or purple. And then from the fake, we have white, silver, gold, or purple. So this is one way it works, okay? But the other one that works as well, we could do this. This is real, white, real, silver, real, gold, real, purple, or we could say fake, white, fake, silver, fake, gold, or fake, purple. So according to this, who is right?
Mm.
Guys,
Fake?
who's right? Rana or Noor? No?
I can't tell.
Well, first of all, look at the diagram I did here. See this diagram? Did Noor make this diagram?
Yeah.
Yes, so he's right. Let's look at Rana. Did Rana make this diagram over here on this side?
Yeah.
Yes, so they are actually both correct.
Oh,
They are both correct because both of them are in fact sample space. Okay. Let's look at number 6. Wholesome Pizza surveyed a random 40 Trinity Food Festival attendees about their favorite type of pizza. Of the attendees, 21 said that the sausage pizza was their favorite type of pizza. So now this is interesting because remember what I told you guys before about the sample space versus the population. Who can tell me the difference between the sample space and the population? Say it. Or who could give me an example in the school? What will be the population of students?
like 1,000?
Do you know that for sure though?
No.
Okay, so give me something that's more tangible, something more real. So, but you're close, Elijah. Yeah, I think you're on the right track. What will be something that is the population of students? When I refer to the population of students, what would it be?
Boys and girls.
That's good. Or you guys could say what? Every student in the school, right? So I want you guys to first understand what population means. So population, let's say in our situation is every student at school. Is everyone good with that?
Yeah.
Yeah? So
Mhm.
now we want to go ahead and find out a sample. What will the sample be? We already talked about population. What will be a sample now? Huh? Okay, I'll tell you. What grade are you guys in?
7th.
So the sample will be 7th graders. Do you guys see it?
Yeah.
So let's think about the voting here in the United States. What will be the population for the United States for voters?
People over 18 or 18 or over.
18, yeah, or older. That'll be the sample. To be more specific, 18 or older who is eligible to vote, right?
Yeah.
So now give me an example of a sample space of the population of the United States.
People in there who are 20.
That's it. That's it. Or you can even be more specific. You could do it by territory as well, you know. The people who could vote in Florida. It's not everyone in the United States, correct? Or you could say another sample will be what? All the women who are eligible to vote. Or what else? Or you could say all the people in the eastern United States. So that's just part of the sample. So according to this here, we need to distinguish the difference between the two. We got the population. It says Wholesome Pizza surveyed a random sample. So this is the sample. Now this is important. And the reason why is because from the sample, we can make a conclusion of the total population. For instance, remember I told you guys before in the, when voting comes around, right? And they cast a vote. Let's say if candidate A has 56% approval, you know, and they go to, like CNN has these little things about who would you vote for the president, and you had like around 700,000 people who voted, correct? Well, there's like I think roughly around 2 million people here in Florida alone, but CNN makes an educated guess about the state of Florida who they choose from the sample space. So if 700,000 people voted for candidate, the majority of those 700,000 people, let's say 56% voted for candidate A, then they make a prediction about the total population of Florida that they will most likely choose candidate A even before the end of when they're going to go ahead and announce the president. They're most likely sure that in Florida, candidate A will choose President A. So if we take a look at this here, the sample space here is what? 40 attendees. So this is the sample. Out of those 40 people here, they said that 21 said that sausage pizza. So sausage pizza was their liking. So now it says out of the survey, 21 said the sausage pizza was their favorite type of pizza. There are 1,600 Trinity Food Festival attendees. Based on this data, what is the most reasonable? So this is a good thing, you know, especially if they're in food services, right? If you're gonna go out and sell, and you know there's X amount of participants coming in, and you've known that 21% of your clients like sausage pizza, but now you're estimated to have more than just 40. You need to make sure that you have enough ingredients, enough food, and everything. Why? Because imagine 1,600 people coming in, and if you have 1,600 people coming in, you don't have enough ingredients, enough food, then who's going to get your business? The competitors, right? So you need to make sure that you're prepared, and this is where kind of statistics comes into effect. So if this is a part of the total, we could make from here a proportion. Instead of being now 1,600, now this is a sample, this will be considered the population. We're solving for this number here. How do we solve for that number there, guys?
You divide 1,600 by 40, and that number times 21.
Okay. That's one way of doing it. What's the other way of doing it? Well, remember, this is just proportion, right?
Yeah.
So remember the proportion, you cross multiply and divide, which, Elijah, you're still correct anyways. You could take this, divide it by that, and multiply by that. Or you can multiply these two numbers and then divide. So take out your calculator, guys, and multiply 1,600 times 21 divided by 40. What do you guys get?
840.
That should,
840.
I just took my calculator.
that should be your answer over here. All right. Let's look at the next one. Okay. Put the following events in order from least to most likely. All right. Well, this is number 7. This is number 7 here. Well, Aaron is 0.3. Well, 0.3 is the same thing as what percentage?
30.
30%. Half is the same thing as what percentage?
50.
And finally, Elizabeth is at what percent? 28%. So it says, Aaron, Elizabeth, and Anna are playing a game. The probability of winning the game are as follows. Put the following events in order from least to most likely. So who's the one that is least likely to win?
Elizabeth.
Who's the next person that is least likely to win?
Aaron.
And then let me take this out. And the one that's most likely to win is Anna. So
Anna.
all right, so let's look at this one. Chen has an MP3 player called the Jumbo. The Jumbo randomly selects a song for the user to listen. Chen's Jumbo has 4 classical songs, 3 rock songs, and 2 rap songs. Chen is going to listen 360 songs. What is the best prediction for the number of times Chen will listen to a classical music? Well, again, we're dealing with, again, a type of proportion, okay? So remember the sample. So the sample, we're coming back to the sample, and we're coming back to, let's say, the population or the total amount. So this is going to be number 8. So first things first, how many songs are on the MP3 player? How many songs are on the MP3 player, guys?
There are 9.
9.
9. Yeah.
4 plus 3 makes 7, and 2 makes 9. So these are 9 songs. Out of the 9 songs, he says, how many are classical songs?
4.
So 4 will be on top. So this is classical. You guys got it?
Mm-hmm.
But he also says that he's going to listen to it. Chen is going to listen to 360 songs. So here, look what happens. The total, he's going to listen to this 360 songs. Out of the 360 songs, says what is the best prediction for the number of times Chen will listen to a classical? So this is what we're trying to find. Again, we have a proportion. How do you find this number on top? We just discussed it before. How do you find that answer, guys?
You cross multiply,
Uh-huh.
and then that will give you
Cross multiply and then divide.
Yep.
When you cross multiply and divide, what do you guys get?
I got 160.
Okay, 160. So we know it cannot be A and we know it cannot be B. Correct? So it has to
Yeah.
be between C and D. Which is the most logical one?
D.
D. Why? Because you could never be exactly 100% certain that it's going to be 160 times. So it's
Yeah.
going to be close to 160. It's like, remember when you flip a coin, right? When you flip a coin, yeah, it's 50-50 chance of getting the heads and tails, right? But when you flip it again and again and again, you will never be consistent with you're gonna get a tail, head, tail, head, tail, head every single time. You might get tail, 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 but according to statistics, it should always be 50%. So it's close to 160, but probably not exactly 160, okay? Number 9. So number 9 says, you've decided you want a plant for your room. At the gardening store, there are 4 different types of plants: tulip, fern, cactus, and ficus, and 4 different types of pots to hold the plants: clay pot, plastic pot, metal pot, and wood pot. If you randomly pick the plant and the pot, what is the probability that you will end up with a tulip in a plastic pot? Interesting. So guys, so if we think about this for a second, all right, and this is number 9. This is interesting here. Okay. Well, number 9, it's like picking up a what's it called? An amount from here. Like so for instance, let's say we have a bag. Okay, this is an ugly bag, but it is what it is. There's 4 different kind of plants. So you have tulip, you have a fern, you have a cactus, and you have a ficus. Okay, and then the other bag, okay, you have 4 different kind of pots. You have a clay pot, you have a plastic pot, you have a metal pot, and you have a wood pot. It says if you randomly pick the plant and the pot, what is the probability? Okay, what is the probability of you picking a tulip in a plastic pot? Tulip and a plastic pot. So the probability of tulip is 1/4, and times the probability of picking a plastic pot, which is this one, is also going to be 1/4. And the key word here is random. Random means that everyone has an equal chance of getting picked. So the probability of you picking that is going to be 1/16. Okay. Why? Because you multiply across probabilities. You got it?
Okay.
So this would be 1/16 will be your answer for this one here. Okay, next question. So here we go, the last one. So it says, the following dot plot shows how many pets each customer owned before entering Jeremy's pet store today. Each dot represents 1 customer. All right, let me see if I find space here. Okay, I have a little space here on top. Right over here. So this is number 10. Okay. So the following dot plot shows how many pets each customer owned before entering Jeremy's store. So 1 customer came in, he owned 0 pets. Another customer came in, he owned 1 pet. Another customer came in, he owned 2 pets, 2 pets. Another customer owned 3, 3, 3. One customer owned 4 pets. 1 customer owned 2 customer owned 5 pets. 1 customer owned 6. 1 customer owned 7. 1 customer owned 8. Based on this data, what is a reasonable estimate of the probability that the next customer to enter Jeremy's pet store, has exactly 3 pets? Well, we got to check this out. And the thing we have to do is this. We have to look at, out of the 10 customers, I think there's a total of 10 customers that came in. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's 13 customers that came in. You guys got it?
Yep.
Out of the 13 customers that came in, 3 of them own 3 pets, exactly 3 pets. So if we take this and do 3 divided by 13, we get a probability of 0.23. 0.23. So it says we could expect more or less, okay, that the next customer that will come in will have a 23% chance of owning 3 pets. So this will be your answer, which is 0.23. All right. Any questions for the unit test for statistics and probability?
Nope.
No.
Okay. So I want you guys to work on this part right here. The other part for geometry is also on there. I know, Elijah, you said that some of the questions weren't on there, all right? On Wednesday, I'll do it again. So you guys could have, more or less everything on it. Let me go ahead and stop share real quick. And let me stop recording real quick.